Okay, so hello everyone again. Hello for those who join the Energy meeting. And welcome to this meeting that I will co-chair with Laurent today. So before we start with the meeting, just some notes as usual. So if you can move to the next slide, please. Okay, so for the noteware, again, audio and video recording. So just to let you know that the IETF 14 makes recording of online and in-person meeting, including audio, video, and photographs, and publishes recording online. And in particular for this online meeting, as you participate online, and that when you turn your camera on or your microphone on, then you consent to appear in such recordings. Next slide, please, Laurent. The privacy and code of conduct. So as a participant in or attendee to any IETF activity, you are acknowledged to that written audio and video and photographic records of meetings may be made public. Personal information that you provide to IETF will be handled in accordance with the privacy policy at the link provided in the slide. As a participant or attendee, you agree to work respectfully with other participants, and please contact the Ombuds team if you have questions or concern about this. You may also refer to the mentioned IRFCs here for more information. Next slide. So the goals of the IETF, the IETF conducts research. It is not a standard development organization. The IETF focuses on longer-term research issues related to internet, while the parallel organizations, the IETF, focuses on shorter-term issues of engineering and standards making. While the IETF can publish informational or experimental documents in the IRC series, its primary goal is to promote development of research collaboration and teamwork in exploring research issues related to internet protocols, application architecture, and technology. And again, here you have the reference to IRC 7418 for more information. So as already said, so this is an online meeting, so the session is being recorded. When you are not presenting, please mute yourself and put your video off. And when speaking, please start by stating your name and affiliation. Here you have some links. In particular, we have the link to the notes that you can also participate into the CodeEMD link. And note that after the meeting, the video will be put online in the YouTube channel of the IETF. Next slide. So the agenda for today, so there will be the short introduction from the ILG chairs that we have already started, but that will continue. And after that, we will have a first set of presentation regarding the status of draft about IBM, one on network management intent and the other one about interconnection intents. And as a bit of follow-up of the previous meeting, also we have a second set of presentation related to digital twins with a first presentation that is not directly related to a draft. It is a presentation of a project, and then we have two presentations related to a draft. And at the end, we have another presentation about an AI framework for network management that will be presented. So just in this introduction, just to make you a kind of status regarding our research group documents. As you know, we have two documents. I think there is a bit of typo in the second document. So the first one is about the two are about the IBM. The first one is about concept and definition, and the second one about the classification. So just to let you know that, as you may have seen, this document has been sent for the IETF chair review, and we received the review for both of the draft in September. With as kind of results, first a set of discussion on mailing list regarding the different comments, just for clarification and see how we will proceed with the different comments. So actually, there are the first one about a concept and definition draft is a revision is under preparation to take into account the different comments. And the other one, for the classification draft, there has been an updated version that has been proposed with still some minor comment to be addressed. But mostly for this draft, the next step will be to see will be under for the mailing list and with a new revision to see if they fulfill the comments we received from IETF chair review before we proceed further with the drafts.
Could you just please update the slide because it has twice concepts and definitions?
Yeah, I've seen that when I read the slide. Yeah, sure. I don't know, Laura, if you want to add something related to this.
Okay, yes, I'm editing live the update to change the mistake in the slide, so this will be corrected soon. Yeah, so the two documents are in discussion between our IETF chair and the shepherd and the authors. We are going through a round of different exchange. The updates have addressed part of the IETF chair comments, but we still have to go through a round of alignment for that. We hope this will be progressed soon. I don't know, maybe asking the authors, I don't know, Olga or authors of the concept definition draft, if they have to share anything right now.
From the classification draft, we would be adding some things in relation to the relationship to the research and some references and updating the introduction and conclusions.
Sorry, Olga, could you repeat a bit because it was a bit cut?
Classification draft, we are making the final changes based on the comments of the chair, and we will be sharing the version hopefully this week.
Okay.
So that's the target.
Okay, Olga, I suggest we have maybe a round of discussion between us so that we can see how we address the comments. If you like,
Okay.
I can be available this week to discuss this with you.
Excellent. Please, would tomorrow, would you have any time? Okay, we'll do it offline. Okay, thanks.
We check something. Okay, good. Thanks,
Thank
Olga.
you, bye.
Okay. If I may just add something as a co-author of the draft on concepts and definitions, we have gathered also to see how to address best the comments from the IETF chair. So there is a new update of the draft pending, and we have a few proposals to address the positioning with respect to the research work being done on IBM and to better position the draft with respect to that. So we hope to be able to release the new version again this week still, and hope this will be addressing the comments from Colin. Jerome, that's it for me on this. Okay, we have Colin on the line.
Yeah.
Hi, tempted to say long-time listener, first-time caller, but I won't. So, yeah, if it's useful to have to schedule a call to talk about these comments, then I'm happy to try and fit that in this week or next week.
Okay, perfect. Thanks, Colin. I think we will, of course, keep you in the loop. I think we have something to do now more on the offer side to make sure the updates are satisfactory, and then, of course, we can check with you.
Perfect.
Okay, sounds good.
Okay, just one slide, I think, one before. Yeah, so just for future meetings, so we'll continue, of course, with virtual meetings. We try to have it monthly. We will try to continue to have it monthly. We were not so much regular in the last month. As you may have seen, I think there was a summer break, and then we have, of course, I think we are all a bit, let's say, overwhelmed by various remote meetings that we have each on your home. But anyway, we will try to resume a bit more the different activities we have in the group, in addition to this, of course, IETF meetings. In particular, we want to resume the activity regarding, let's say, the actual network embedding SFC and slicing. There are some propositions, and to have a workshop around these topics. So I mean, workshop or virtual meetings. So we try to organize it. And also regarding the AI research channel document after summers, we had input during summers, but we did not yet consolidate, and so we have to also to organize dedicated meeting to make it more, I'd say, more consolidated, to have something also which can be reviewed and more integrated, let's say. So anyway, yes, there's also the mailing list, of course, different tools that we have on collaborative platforms. So do not hesitate to use it, or to also propose if you have any ideas or topics you would like to discuss in the group. It's also still, it's of course open to any ideas. And yeah, that's it for me. If there is no question, comments, I think we can continue.
Okay. Any question from the research group? Seems not. Okay, nothing in the chat. Okay, so let's proceed with the agenda. So our next is
it's a network management, and so Danyang.
Yeah. Open it.
Hello everyone. I'm Daniel from China Mobile, and I'm a colleague of Daniel. Can you hear me?
Yes, we can hear you well.
So shall I start now?
Yeah, yes, you can start. Yes.
Okay. So hello everyone. So this is the third update of the original draft network measurement intent, and I'll first briefly talk about the updates of the draft, and then I want to call for some suggestions on the stage of the draft. So next page, please. So we can see in the diagram that this time there is not very much many updates compared to the draft presented in the last meeting, and the major update is the procedure. The whole procedure in the diagram at the right side of the slide. We can see that in the original diagram, in which the model NMI policy is an independent part of the whole procedure, it only communicates with the translation module, which we think is not very reasonable and accurate. So next page, please. The left side lists the original procedure. So we think we move the NMI policy model inside into the whole procedure, where it connects the NMI translation model, compliance assessment model, and orchestration model together. So it is the breakdown, which we think is very reasonable now, because in original procedure, the output of translation is some policies, and the outputs of compliance assessment is the result and some decision whether data analysis result is matched with the network measurement intent, and the input of whereas the input of orchestration module should be some policies or actions according to some templates. So they are not very matched. So we moved the NMI policy model inside the procedure, and now the outputs of translation model and compliance assessment model will all be translated into some policies according to the templates inside the policy model, and these templates will change these change the results to some actions where which need to be inputted into the orchestration model. So next slide, please. So this time so this is the major update we think we should modify in the whole procedure, and we think that so next slide, please. I've already stated about the updates in this time, and since the draft has been updated for 3 times, and we have already shown the necessity in defining and satisfying the network measurement intent, we could know how network behave through the process. And so we think that the draft is relatively stable right now, and we are asking for the permission of chairs and other participants if the draft could be adopted, or if it's still in early stages. And if it's not so mature, we wonder if we could start writing the draft that the intent-based network use cases, because we think network measurement intent is it's a very important use case of IBM. So we have sent emails to chairs for several times, but we haven't get any reply. So we wonder if how to promote this draft. So if anybody is very interested in the topic, and you can send emails to us, we can promote together. So that's it. Yeah, thank you.
Okay, are there questions in the audience for this draft update? Okay, I don't see anything also in the chat. Also, so to address your request for research group adoption or the next step of the document, so I mean there are different things we could clarify. First, a bit. I mean, in the research group, there is no, say, official way of adopting a research group document. Okay, it's not like in a working group where you have a specific process that is established. Nevertheless, in the NMRG, in the last couple of years, we have defined a procedures to assess the maturity of documents that you would like to adopt as research group documents. So we can point you to these procedures, and if there are requests from you to do that, we can start the research group call for adoption. The things we are trying to look for maturity in terms of research group documents are based on several aspects. So essentially, if the work is mature enough, if the scientific work that is being addressed is complete, and what types of research output are produced. We're also looking, I mean, for technical soundness of the overall documents, and also if the document is in good shape. And the final thing we are checking is if there are enough support, either from the authors or other participants in the research group, to actually move the work forwards up to a kind of completion. I mean, what will be the if we can complete publication of this document in what will be the form reading by the authors, so that we can publish the outcome of this research as part of an outcome of the NMRG. Just a comment from my side on this intent-based network use cases. I think this is good because we had in our IBM work plan an item to study different use cases for intent-based networks, especially after we had the initial concept and classification draft being laid down, where we stand now. So it's good to have this network measurement intent as a proposed use case. What is still unclear, and we have to work this out as a group, is whether we want to have a collection of individual use case drafts on different topics, or if we want also to have a kind of a single document that takes multiple use cases and tries to reflect on either commonalities, differences, and learnings across the use cases. We initiated that some time ago. It was not clear which way we go with the group. I think now we have 2 to 3 different use case drafts that we can maybe try to work together and see if we want to keep them independent and or also to consider taking part of them into a common document. So I think we are at a nice step in terms of progressing this work, but it's also up to the research group, in fact, to decide, the authors and the research group to decide what they want to do next with this document. And I will also the floor to Jérôme to know if he has anything to add on this.
Yeah, thank you, Laurent. I really agree with you, and that we can work together with other companies in promoting the internet network use cases. But I think that right now there are, as you said, there are 2 to 3 different use cases listed in the working group. But I think we are studying from different dimensions. You know, the use cases are from different dimensions. So I think we could talk with other groups to study how to promote and how to work together to work on the use cases, and we will exchange ideas and by email or other meetings. So if anybody are interested into this topic, you can send me emails. Thank you.
Okay, thank you. So a couple of things. We have a comment in the chat from Charles that mentioned that there is an existing draft in MEF, Metro Internet Forum, that may be of interest to the authors. So there is a link provided to that. I will put that into the notes of the meeting. So if authors want to refer to that later on, that is also possible. And Charles, if you want to make a live comment, don't hesitate. We still have a couple of minutes to help our authors here. The second thing I would like to mention is that I think the first step for the kind of IBN use case draft, like network measurement intent is, would be nice also maybe to connect explicitly to the classification, you see, because we have seen in the past that it's useful to try to position, reuse the work done in classification. And if we have across different use cases, common references to the classification work, this could also be very useful, I think, as an output of the group.
Okay, thanks.
Charles, go ahead, please.
Okay. Yeah. So the draft. This is Charles Eckel, and the draft that I mentioned, it's really looking at SD-WAN as the use case, and then from the point of view of applications that are identified by the networks, measuring performance of them in the context of SD-WAN. So a bit more specific, perhaps, than what you have here with the intent-based networking. But I think a lot of intent-based networking does focus on the applications on the network, and so that's one way, sort of interpreting intent or capturing intent. So that's why I mentioned this draft may be of interest. I think it could be worth looking at. What's the link to the draft? It is a draft. It hasn't yet been published as a MEF standard, but it will be relatively soon. So anyways, now would still be a good time to have a look at that and provide some feedback based on it.
Yeah, thank you.
Thank you, Charles. Useful always to have a different perspective. I think authors will consider that in the discussion or revisions. Thank you. And just to mention also, Robert Wilson also mentioned a useful reference that could be added to the document, which is on the network telemetry framework from Ops Area Working Group. So it's already part of the notes. So authors, you can also have a look into the minutes after that if you want to have the pointers mentioned by Charles and Robert. Okay, so Jérôme, if you're okay with that, and we have no more questions from the room, we can move on.
No, I don't have any other comment, Laurent. I think
Okay. Okay, so just because we still get some input on the chat, so I invite authors to look at the chat. Benoit also mentioned something, and everything will be posted anyway in the minutes. And now we switch to the other presentation. Thank you.
Okay, so next presentation is about the interconnection intents. It will be presented by Luis.
Yes, thank you, Jérôme and Laurent. I think that the slides have been uploaded. I cannot see them yet. Okay, now I can see them. Okay, thank you very much. So yeah, I will present this update on the interconnection intents draft, with essentially try to explore the applicability of the intents for interconnection in a wide sense, in a wider sense. So next, please. So regarding the draft status, there was a first version presented already in IETF 108 in July last year. This version presents an update. I will comment on some of the points later on. And also, just to highlight the fact that Paolo Lucente is also added as co-author of the draft. We, Paolo and myself, we have already identified new content that is expected to be included as a new version for IETF 113. And today, essentially, we will comment on what is present now in the draft. So next, please. Okay, regarding the motivation and the objectives of this work. So essentially, what we are perceiving or what we are seeing is that in the present mode of operation in the interconnection world, essentially, this interconnection is only conceived as a pure interchange of IP traffic, so no more than that. These environments of interconnection for peering and transit essentially require long interactions between parties. Is typically static in the fact that you establish a session and essentially maintain that session along the lifetime of the agreement for interchange IP traffic, and well, it's somehow based on manual operation at all. So the situation is changing in the fact that the operators are now start to deploy computing capabilities, and this is coming with the advent of cloud and edge computing, and also with the advent of virtualization. So existing model for interconnection is limited to that interchange of IP traffic. So we were wondering how to leverage on intents for evolving such a way of interconnecting and taking into account those other capabilities that allow to request for more advanced services. And here we are considering services like the ones that could permit different stakeholders to deploy virtualized services, for instance, in different domains, or to leverage in compute capabilities of any other domain in order to instantiate later on whatever virtual network function or container or so. No? And clearly here, an example of that could be to instantiate a service function chain in a multi-domain environment. So somehow we are trying to address and to explore such kind of scenarios, leveraging on these novel capabilities that exceed just the pure interchange of IP traffic. So next, please. So regarding the summary of the draft contents, so again, the target is to leverage on the intent mechanisms in order to enrich the interconnection request. So going further of that pure traffic interchange, and the scenarios of applicability, we mentioned before one of the typical one, let's say, between operators, but also is clear, probably important to highlight the situation that is also being fostered by the advent of 5G networks, where there is this idea of interconnecting private networks to public networks and so on and so forth. So it's not just, I mean, moving from pure peering and transit to something else involving further capabilities, the compute, the edge, and so, but also different actors that are not, let's say, well, that probably today are not so much present in the real deployments. Clearly, multi-domain network as a service request or multi-domain network virtualization will be also target of this kind of interconnection intents. Regarding the modes of usage of this interconnection intents, we would have the baseline one that would be the IP traffic interconnection, so peering transit, but also we are foreseeing other scenarios, like could be, for instance, express service intents, like could be the ones, for instance, for the CDN interconnection that is work also in IETF CDNI working group or in the Streaming Video Alliance. Other usages like a virtual network function as a service. So, and here an example could be, for instance, the deployment of packet walk capabilities for virtual network operators. And maybe here we just as a guessing of what other tools in IETF could be used. Maybe this service function aware topology model could be used for that. Also to use these intents for interconnecting computing capabilities, for instance, instantiating functions or containers on top of them, and maybe leveraging also in some other drafts that are being presented in other working groups in IETF, or any combination of all these usages I have mentioned before. So essentially to make a broad scope of different interconnections that are now or are expected to be allowed now with these new capabilities in operator side. So the benefits of these intents will be to establish a common and a normalized way between service providers, but also private networks, in order to automate the interconnection and look for a simple way of expressing enriched interconnection requests, again, going farther than the pure IP traffic exchange. So next, please. So as next steps, we will work developing in these intent-based capabilities for interconnection aspects, trying to explore more details on that, and some further details not present here in the slides, like the policies, or maybe also extend to different kind of technologies, optics, and so. Also to request comments and inputs from the audience, from the research group audience, in order to enrich the document for sure. And again, also, we would like to position this draft as one of the potential intent use cases that are being developed in this research group. Yeah, and well, here probably the same comment as before, at the presentation before. So that's all from my side. Thank you so much, and for sure, I'm glad to answer whatever question.
Thank you, Alois. Do we have questions from the audience on this draft? Okay, I have one question. Just coming back to one of the slides. When you're mentioning different, enriched interconnection requests between different actors, do you see the main, I would say, segments like being into inter-carrier exchange, or it's more like between different operators at any point, or between different actors like vertical type of actors and operators? I mean, for this interconnection, what kind of environment do you see?
Yep, the starting idea, let's say, come from the interoperator interconnection, but we think that can be extended to any other scenarios as soon as we could abstract, let's say, the way of requesting these intents, these capabilities. Sorry, so probably could be applicable for all of them. At least this is my view. But the starting point was for sure interoperator interconnection. Yes.
Okay, thank you. I will put in the minutes, but I come. There was a recent publication. I don't remember if it was CNSM or another conference that was addressing inter-carrier exchange automation, and I think they were referring to some kind of level of abstraction. So this may be a reference, a useful reference for this one.
For sure. Thank you so much, Rowan.
Anything else? No other questions, nothing in the chat. So thank you, Luis. We proceed with the agenda. And hopefully, let's see if we can also come up with something in common for these different use case drafts around IBM. Thank you.
Thank you, Luis. So next presentation is digital twins for industrial IoT networking, and Chiara Grasselli.
Can you hear me now? I'm talking from the office of Franco Callegati, so I'm using his computer.
Okay, no problem. You can hear it.
Okay. Good morning to everyone. I'm Chiara Grasselli, a PhD student at the University of Bologna. During this session, I'm going to show you and present the activity me and my colleagues have carried out on digital twins for industrial IoT networking. Next, please. This activity is actually part of a project called I4S that started 2 years ago and now is almost at the end. This is a project funded by our regional government, and the focus is cybersecurity on industrial and manufacturing environments. So some of the objectives of the project were the identification of possible weaknesses and assessment of cyber risk level in connected production plants where, for example, IoT technologies are applied or used. And more, another goal was the identification and implementation of solution, of course, to improve the cybersecurity level. In our particular case, actually, our group focused on the emulation, the creation of a system able to emulate the real network architectures to perform some cybersecurity testing, for example, technological validations and training in general. Next, please. In our activity, we combine two principles. The one of the cyber range. A cyber range is an environment for cybersecurity training, technology validation and testing, and the idea of digital twin. A digital twin in our case is a virtual replica of the real system, so the real network architecture, manufacturing and industrial network architecture. And due to the constraints of the project and the context of this activity, we actually wanted the digital twin completely separated from the real twin, because we couldn't interfere, of course, with the real productive lines and plants. So what we have implemented is a digital twin that we use for as a cyber range environment for testing. For example, we carried out some simulation of attacks and so on. Next, please. In this work, we have exploited our expertise on virtualization technologies and paradigms such as NFV, network function virtualization, and software-defined networking. And in particular, we follow the ETSI management and orchestration functionalities and framework. The ETSI framework covers for example, allows us to design the architecture with high-level description of the architecture. Then to describe each building block, each element we want in our digital twin, and the topology, so how we combine all the building blocks together, how we can interconnect them with templates called descriptors. I will show you later in the next slides the types of descriptors. And finally, the ETSI management and orchestration allows also to have an automated deployment. So with this, we could have an automated deployment and configuration of all the components of the digital twin. Next, please. This is, in this slide, you can see a picture of the reference architecture. This is a general figure. We consider some of these elements for the actual deployment. You can see that we can have one or more production plants with IoT connectivity, one or more gateways. It depends on the protocols we are using in this environment. And then we have other elements that are not related to the real production, to the production plants, but are more operative and for the enterprise part of the network. So we have we can have VPN servers, VPN nodes, firewall, an intrusion detection system or prevention system, big data analytics, and so on. And in our case, all of these components have to be replicated into a virtualized replicas. With virtual machines or containers, both approaches are possible. We selected the one based on virtual machine. And we exploited network function virtualization to emulate the network architectures, all the functions that are called virtualized network functions in the term of NFV, and the application into virtual replicas too. Next, please. Since we use the NFV management and orchestration framework, actually the digital twin lifecycle is quite similar to the one of a network slice. We have different phases of the lifecycle. One is a pre-phase, is not actually a real part of the lifecycle. It's the preparation phase during which we can design the architecture. We must design the architecture of the digital twin with descriptors. Once the descriptors are created, we onboard them on the orchestration platform. And here we can have also some additional network environment setup. For example, we needed additional networks to have access to the external world, for example, and for management functionalities. Then we have the commissioning phase, where the digital twin instance is created. So all the components are all deployed automatically. And then we have the operation phase, when all the components are up and running, we can monitor and reconfigure them as needed. And finally, once when the digital twin is no more needed, we can eliminate all the components. And so we have the decommissioning phase where all the resources also are released. Next, please. Here you can see the software we are using and that we have chosen for this project. Open Source Mano, that is the management and orchestration platform, NFV management and orchestration platform promoted by ETSI. And this is the orchestrator with some other management functionalities of the lifecycle we had just seen. And then OSM is integrated with OpenStack. OpenStack is the infrastructure as a service platform that we use to have compute, networking, and storage resources. And in terms of the NFV framework, is also the VIM, the Virtualized Infrastructure Manager, that manages the allocation of resources as needed, specified in the descriptor. Next, please. Here you can see the picture that sum up some of the concepts I've talked about in the previous slides. We start the deployment from high-level descriptors. So you can see two types of descriptors here. The VNF descriptors are the one for each building block. That this type of descriptor tells what are the characteristics of each VNF. So each of element of the digital twin And then we have an upper level type of descriptor that are the network service descriptors that describe the topology, how we want to combine all the VNFs, so how we want to combine all the elements in our digital twin. And then we need also to upload, for example, in our case, we have a deployment with virtual machines, so we need to upload the cloud images we want to use. Then we have the orchestrator that can talk with the infrastructure as a service platform with OpenStack, and the management functionalities are actually shared by both platforms. We have some functionalities in the orchestrator, in OSM, and some in OpenStack. Next, please. Here you can see a list of the components we consider for our deployment. As VNF, sorry, we had as VNF, we can have a big packet inspector, intrusion prevention system or detection system, firewall, traffic shaper, VPN server. Some of them were already in the reference architecture. And as virtual application, we can have different type of also protocols, application with using different protocols, the traditional industrial protocols like CANopen, MQTT, Modbus, and LoRa. Next, please. Finally, here you can see the actual deployment of our digital twin, the current deployment. We implemented the elements that you see outlined in dashed lines in this figure. We have, as I told you before, we needed two networks for to be present before the instantiation of the digital twin. These are the blue one for the external connectivity and the green one for the management functionalities. With the instance, we create also a management console for this purpose. And then we have a firewall. The other one are all VNFs. We have a firewall, an intrusion detection system based on Suricata, and an internal router. Plus, for the more related industrial part, we have a virtual machine with a Modbus traffic generator. To simulate the possible cyber attacks and so on, we used a Kali Linux machine. You can see also this one in the figure. Next, please. Here we have just only a slide that makes a reference to one of the models usually used to layer the infrastructure in the industrial and manufacturing environment. It is only to say that we have a part more related to the field and production plants, the one for operation and the other one for enterprise, which actually are in our deployment are overlapped. Next, please. Now, I'd like to show you a short video demo of the deployment and an example of a possible attack we tested on the digital twin.
Okay, Chiara, is it good if I just start the demo, or you want to run it on your PC?
Maybe if I can share the video myself, it's better, because so I can stop when I want to comment and so on.
Okay, so you have to request screen sharing.
Yes.
Okay.
Okay. So the first part of the video is about the orchestration and the instantiation of the digital twin. Okay, here we have the graphical interface of OSM. We need, of course, an account. And first of all, we need to I will stop for a moment with the video. We need to define the logical connectivity between the OSM platform and OpenStack platform. So this can be done with the Vim accounts, the so-called Vim accounts. So basically, we only specify the type of the Vim, the tenants, for example, the password, and the user we want to use, and in particular, how to reach the Vim. This is needed for, of course, the deployment later. Here you can see the part related to the description, how we can create the descriptors. The main descriptors are already onboarded in the video in the OSM catalogs. You can see here the VNF, which correspond to each element of the digital twin. We have firewall, gateway, IDS, and so on. This is the list. And here you have an example of one of them. In the descriptor, we define the ID that is used to reference the descriptor. Then we have the most important part is the VDU, the deployment unit, which specify the, for example, the cloud image we want to use for the VM, additional configuration files, the interfaces we want to create for the machine, and finally the flavor, the resources we want to allocate to the machine. Here you can see, on the contrary, the other type of descriptor. We have network service packages. The descriptor are inside the package. In the network service, we put together the components we want in the final deployment. So we have the list of the VNFs, and we define the virtual networks link, the descriptor, virtual link descriptor that corresponds to the network that interconnect the VNFs. This is an example. And we can define, of course, also, for example, IP addresses if needed, or other parameters. Once the descriptors are ready, we need to upload them on the orchestration platform in the catalog. This is an example with other descriptors that were not present before in the catalog. This is a simple drag and drop procedure. And finally, we can launch the instance now that we have the descriptors. So we need to define, we need to select the descriptor you want to create, to deploy. We define a name, a description, and most importantly, we need to select a Vim for the deployment. So here you can see what is going on OpenStack during the deployment. The blocks are the VMs. They are pop-upping during the instantiation, and then we have the vertical bars that are the networks. Some of them are actual networks, and the other one virtual inside the OpenStack platform. And here were the list of all running components. This is an example, finally, of a possible attack on the Modbus using the Modbus protocol. We have the Kali Linux machine and the node with the traffic generator, the Modbus traffic generator. Here we are performing a massive reading of the Modbus registers, for example, from the Kali machine to the other node. And this is an example how we can configure the IDS, the intrusion detection system, to detect this type of behavior. So on the right, you can see, in the right part, you can see the terminal with the output from the intrusion detection system. This is all. So thanks for your attention. And if you have questions, of course, I'm here.
Thank you, Chiara, for the presentation. So, any question or comments from the audience? Okay, so looks not. And thank you again, Chiara, for the presentation. And if there is more comment on the mailing list, we will forward to you.
Actually, I do have a question. Because if I understood correctly, you have set up different virtual environments. But how do you relate that to the aspect of a digital twin and having the opportunity to see link between what's actually happening on the, for instance, the digital plant, the factory, and I mean, what you monitor from this environment and how you can run, for instance, simulation in the digital twin and retroact on the actual environment. I mean, can you give us a bit of your feedback on this interplay between the real network environment or the real IoT environment and the digital twin?
Yeah, so the question is about how we can actually interface to the real network, right? This is actually the focus of some of the other research groups, the other partners of the project. Some of them provided some software to interface, for example, with the actual production plants and the industrial networks, with Canopen, for example, and Aurora One technologies. And we once in a previous deployment, not the one in the video, we actually included this part also in our digital twin. In particular, the one related to Canopen. There is also I think in one of the figures I've shown you, in the figure you can see also a node with the Canopen protocol. And then actually we don't have also a real-time monitoring because due to the constraints we wanted something completely separated from the real twin. Yeah. Here you can see also a Canopen node. I don't know if this is what you were asking.
Yeah, thank you. It helps. My follow-up question would be, you have for instance, showed in the demo video like an intrusion detection system that run into the virtual twin. Do you have other typical scenarios or types of functionality that you simulate into your digital twin, or is it work in progress? Just to know a bit the breadth, the number of let's say functionality you are able to simulate, or what kind of functionality you simulate for this kind of environment.
We actually had some industrial partners in the project, and we are getting now feedbacks from them. So we are waiting for them in order to maybe try different types of attacks and scenarios. It depends on what they are interested in actually. So we are waiting for them, and we are working now on this part because this is the last part of the project. So we are waiting for feedbacks in order to proceed with the other testing.
Thank you. Yes, Shane, go on, please.
Can you hear me?
Yes.
Yes, we can hear you.
Okay. Here's a question. Can I know whether you have run performance test on your solution? I wonder whether this solution can support a large-scale network simulation or digital twin solution. So is the resource cost affordable? Thank you.
Can you hear me right? This depends actually on the available hardware and resources on the cloud platform. I would say yes. For this testing, of course, we use some not so powerful hardware, actually, the one we had here in the lab at the university. But in principle, if you have more resources, you can have a larger scale deployment, for example.
Okay, thank you. I think we have no more questions on this presentation. Thank you a lot, Kevin, for preparing the slide and the video, and good luck for the rest of the project. And anyway, if you have follow-ups, we will be glad to hear more from the research output that you are progressing on. Thank you. So let's move to the next presentation in your agenda. Hong, you can go on, please.
Can you hear me?
Yes, we can hear you.
Okay. Hello everyone, this is Hong Zhu from China Mobile. My presentation is an efficient data collection method for digital twin network. And related draft can be found on the website. Next, please. Okay, this draft consists of 7 sections, including introduction, overview, conclusion, and advantages as well. Next, please. In this slide, I will present the background and introduction. Digital twin network is defined as a network system with physical network and twin network, which can be mapped interactively in real time. So the construction of digital twin network requires real-time data of a physical network to update the state of a twin network. In face of large network scale, net collection, storage, and management are faced with great challenges. However, the existing method collects the full amount of data from the physical network for modeling and doesn't exceed the problems such as time lag, insufficient storage resource, low computational efficiency, and waste of bandwidth resource caused by data transmission. Therefore, it is important to propose a lightweight and efficient data collection, aggregation, and correlation method. Next, please. In order to solve those problems, this draft introduces an efficient and lightweight data collection, aggregation, and correlation method. Twin network sends instruction to a physical network to collect data on demand, and then the physical network complex instruction such as knowledge representation, telemetry streaming element of physical network complex data aggregation and correlation. Finally, telemetry streaming element sends the processed or represented data to the twin network. Next, please. Next, I will introduce the details of draft. The main modules involved are shown in the figure. The digital twin network consists of physical network and twin network. The physical network includes multiple data storage centers and telemetry streaming element, which is proposed in the draft of a network telemetry framework. Also, the twin network includes the instruction management center and data storage center. In the next few pages, I will introduce the main functions of each module in detail. Next, please. This page will introduce data storage set of physical network. It has it has two functions. Firstly, it can store data such as performance indicators, operational status, logs, traffic scheduling, and business requirements, and so on. Secondly, it has the function of automatically parsing the instruction set by the instruction management set in the tree network or set by the telemetry streaming element. Next, please. The telemetry streaming element in the physical network has the following functions. For example, data collection, data aggregation, data correlation, and data query, and so on. Next, please. The tree network includes the instruction management set and data storage set. And the instruction management has two functions. On the other hand, it may use to manage the registration of telemetry streaming element in the physical network. On the other hand, it is used to adaptively configure data collection instruction according to the collection requirements of the data storage set in the tree network, and search for IP address to set the instruction. Among these registration information include various key information, such as the IP address of the data storage set in the physical network, data type, and various index names of the data, data source name and data size, and so on. Next, please. And the function of the data storage set in tree network is mainly used to store the effective information after data processing and the knowledge representation returned by the telemetry streaming element in the physical network. Next, please. Next, I will introduce how produce a data collection. Step 1, the data storage set in the physical network register with the telemetry streaming element in the physical network. The telemetry streaming element register with the instruction management set. The registration information includes the IP address of the data storage center and the data type and data source or the data size and so on. Step 2, the data storage set into a network sets the data collection request to the instruction management set. Step 3, according to the data collection request, the instruction management set intelligently queries the registration information for addressing and configure the data processing instruction. Next, please. Okay. Step 4, the instruction management set in the tree network sets the corresponding instruction according to the query result to the telemetry streaming element in the physical network. Step 5, after receiving the instruction, the telemetry streaming element in the physical network will pass and execute them according to the instruction and query the local or data stored. The query function can be performed by the complex event processing engine, which resource all telemetry data and process it with all queries provided. Step 6, The telemetry streaming element sets data subscribed to data storage set of the physical network. Next, please. Okay. Step 7. Data storage set of physical network performs knowledge representation of local data. For example, in resource description framework form, also sets run data to telemetry streaming element for knowledge representation. Step 8. Data storage set of physical network push data or knowledge to telemetry streaming element. Step 9. Telemetry streaming element aggregates and correlates the collected data or knowledge. Then, according to the actual needs, divide whether to perform knowledge representation. Step 10. Telemetry streaming element sets the processed data or knowledge to data storage set or twin network. Next, please. Okay, this draft has the following advantages. Firstly, the need for storage resource in the twin network is reduced. Then the need for computing resource and improve the efficiency of data processing and representation is reduced. Next, and the bandwidth resource consumed by the data transmission is greatly reduced. Finally, data transmission latency is reduced. Next, please. Finally, I will analyze the instruction carrying information and discover more concrete examples of data collection and consider about the extension. Okay, thank you. Any question?
Thank you for the presentation. Is there any comments or question?
I have a question, but I'd like to hear from the floor first.
Okay, we'll do one.
Okay. So thanks for this work. It's interesting direction. In fact, my question is also a comment. I think it's an important question in digital twin environment to consider the performance trade-off to get accurate data about the real environment and to balance that with the cost of collecting this data. Okay, so the fidelity from the need. So two things. First, I think it's we need to be careful because the notion of digital twin, I insist on the twin, is that we need to have a very accurate representation of the real environment. So it's not approximate. It's not. We really need to be very close to the real, because the idea is to be able to replicate and simulate so that we really see how the real one will behave and be able to use that to make useful simulation and scenarios to be able to help or to support the real environment. So I think there is this question of how far we can get into saving on the data collection and data representation without compromising this twin approach. So this is more comment. The second thing, and it's a bit my question related to the research that we can do in this work, because I think you touch a lot about the methods to collect data, to aggregate data, and to convey data between the real environment and the twin. So I think this is very relevant as mechanism. But I was thinking about more the let's say the algorithm or the methods, in fact, to understand what kind of data we need. Because I don't think there is a single approach that could fit every need in a digital twin. Depending on the simulation you want to run, you may need very coarse data on a let's say intermediate basis, or you may need to have very high fidelity data on different set of metrics, and even sometimes you need to anticipate on the collection of some some new measurements in order to have them ready when you want to run the simulation in the twin. So my question is, do you plan or do you have knowledge about different methods or different research being done into assessing how we can in fact evaluate a bit in advance or very dynamically what is the need expressed on the twin in terms of data collection, and how we can in fact have methods that can optimize. So I'm looking especially for optimization methods about what to collect, when to collect, etc., so that we get a very good interplay between the real network and the connection, the measurements we do on that, and the need of the twin in terms of having the right data at the right time to make the right simulation. So are you aware of some methods, algorithm to look into this optimization, not the mechanism to transport the data or collect data, but really the intelligence, in fact, to make the right data collection and to optimize this function?
Okay, thank you for your values suggestion. We will update this draft in the next version. If you have any questions, due to our time, please email me to discuss. Thank you.
Yeah, okay. I will. We can discuss offline about my input and suggestions. Okay, thank you. We have also Sheng in the online.
Hi, Lauren. Actually, I'm the co-author for this draft, and I really value your comments. And surely, we data collection or data aggregation or data correlation or data all data related domains are really very big facts for building digital twin network. And currently, the scope of this draft is only for some case of the data collection. In those cases, there is chance to aggregate or correlation or compromise some data, raw data, to get more efficiency, and also can achieve a high fidelity to build the twin. So maybe we next version we need to narrow or clarify the scope of this draft. Of course, another way is that if we want to mention all the cases of data collection, we need to enlarge our draft scope as well, and to answer all your comments and in this draft and clarify more. Thank you.
Okay, thank you, Sheng. Yeah, we definitely need to work together into progressing this work. We can discuss offline, of course. Thank you.
Thank you.
Okay, just for the sake, Mohammed also mentioned a comment in the chat. I think we are slightly on time for the agenda. Let me just check. So Mohammed put on my first comment, I don't think there is an answer for the first question raised by Laurent, as it depends on the application making use of the digital twin. If your app is for training purposes or for running what-if scenarios, routing changes, for example, you don't need a full real-time synchronization or sync between them. Okay, so these were comments from Mohammed in the chat, and we will reflect that in the minutes. Thank you. Let's switch to the next presentation.
Hello? Can you hear me?
Yes, you can hear you, Chen.
Hello, cheers, everyone. This is Chen Zhou from China Mobile. Today, I will present the draft update of digital twin network concept and reference architecture on behalf of our co-authors. Next slide, please. Actually, this is the fifth time to present the draft in this research group. As we have presented since IETF 108, the objectives of this draft includes to define digital twin in networking field, to sketch a reference architecture for digital twin network, and to define identify key values of digital twin networks, as well as research challenges, and also to document typical application scenarios. Next slide, please. Since IETF 111, we updated version based on inputs and comments from both MRG mailing list and internal reviews. Here, I should say give many thanks to expert Ramin, Pedro, and all others. As main changes in -5 of this version, we mainly clarified the difference between digital twin network platforms and legacy network management systems, refined the description of the reference architecture, and added references to digital twin network research. We clarified the benefits of privacy and regulatory compliance. And also, we have also made some other editorial changes. Next slide, please. This table in this slide and next slide lists the major comments and our action taken. Here, I will not describe them one by one in details. Next slide, please. I just give a brief summary. Totally, 20 more comments were raised and addressed, and we have either explained via email or made changes update in latest version. Next slide, please. This slide shows the difference between digital twin network and other network frameworks. As clarified in introduction section, the main difference compared to other network management system is the use of interactive virtual real mapping to build closed-loop network automation. Through the real-time data interaction between the physical network and its twin networks, the digital twin network platform might help the network designers to achieve more simplification, automatic, resilient, and for lifecycle operations and maintenance. Digital twin network allows for integrating AI-based mechanism emulating the behavior of network sections not under consideration, but relevant for the considered section. Also for considering several parallel options or courses of action. And for incorporating real-time monitoring data from physical with other real or virtual data sources, and also for repeating and reproducing specific situations under controlled variations. Additionally, digital twin network also help combines the features of network emulation and the software-based control environments. Next slide, please. This slide shows the collaboration on the reference architecture. In the three-layer architecture, we provided the lowest layer is physical network, and top layer is the network application, and the intermediate layer is the network digital twin. This layer includes three key subsystems: data repository, service mapping models, and digital twin entity management. This time, in this version, we propose an optional sublayer of collection and control. Data collection and change control are regarded as southbound interfaces between virtual and physical networks. And from an implementation perspective, they can optionally form a sublayer or subsystem to provide the common functionalities of data collection and control and change control, enabled by a specific infrastructure supporting bidirectional flows and facilitating data aggregation, action translation, processing, and ontologies. Next slide, please. So about 2 slides, I just described the major updates from last meeting. So for next step, we believe that current staff is quite stable after five times of update. So we are requesting document adoption by MRG. So welcome to join our work, and any comments are welcome. And since time permits, I'd like to share 2 more slides in appendix. So next slide, please. Thank you. Based on the reference architecture we provided in the draft, we suggest that some key enabling technologies for building digital twin networks should be studied furtherly in future. And this slide just lists 5 enabling technologies. The first is data collection, including diverse existing tools, for example, SMP, NetCom, telemetry, INT, etc., and innovative new tools, for example, sketch-based measurement, and also the tools can include semantic and aggregation mechanisms for data integration and action translation. This is first. Second technology is data storage and services. Unify the data repository to effectively store large-scale and heterogeneous network data, and to provide data services including fast search, batch data handling, conflict avoidance, data access interfaces, etc. And the third is data modeling. For small-scale network simulation tool, for example, QS3, GNS3 can be an option. For large-scale network, we believe low-cost solution should be required to create network element and topology models. And AI and machine learning can be used to build complex functional models in twin entity. The fourth technology is visualization, including displaying the network topology operational status in multiple dimensions and fine granularity, and using interactive visualizing to help user better understand, deduce, and explore the network interfaces and protocols. The fifth is interfaces, including twin interfaces, application-facing interfaces, and internal interfaces. They can choose different type of tool or protocol as required. Note that these technologies are not in the scope of this draft, but we believe that based on this draft, they can be studied separately in future in this MRG group. Next slide, please. This slide shows that more researches on applying digital twin to network in academia. More research efforts apply the digital twin concept to network fields, including edge computing system, industrial Internet of Things, 5G network, etc.
Shane? Are you still online? I cannot hear you anymore. Is it the same for other participants?
It's the same for me at least.
Okay, so Sheng, it seems that you've been cut off the audio stream. I still see you online as participant. Okay, offline. Anyway, we have reached the end of the near the end of this slot. I'd like to open up for questions if we can. Do we have questions on the presentation for this draft? Because we have to go also through the request for the call for adoption. Sheng, are you back online? Sheng, can you speak to see if we can hear you?
Can you hear me?
Sheng, yes, try to speak again.
Oh, sorry. My network is broken. Sorry. In this slide, we just want to show more samples on applying digital twin network. In academia, there are several researches in edge computing, 5G networking, and also in industrial IoT. And medical, Ms. Cherria gave us another example. And in industry, more companies are investing in solutions of digital twin networking, including Arrow Networks, NetGreen, Huawei, and Spider solution. So we believe that our work in emerging is the right way and also helpful to clarify the concept of digital twin network, as well to provide a reference architecture to both academia or industry. So thank you. That's all.
Thank you, Sheng. We have Kiran online. Please, Kiran.
Hi, am I audible?
Yes.
Okay, I just have a quick clarification question that when we define digital twin network, is it are there multiple instances that we are abstracting from a physical network, or is it a representation of the entire physical network in one shot?
Okay. In our opinion, that when we said digital twin network, it should contain both twin network and the physical network. It's our opinion and also the point in this draft.
Thank you.
Okay, thank you. So you expressed request for a call for adoption as a research group document, and as said also for the previous draft, we follow let's say a group procedures to validate some criteria to see a bit the feeling of the research group on adopting this as a research group document. So usually we take it offline on the mailing list so that we have time to collect expression from all the participants. I just share my view more as a participant right now. I think it's interesting to see an architecture document for network digital twin. As you say, the document has matured for some time now. So I think it's a good time to have this call for research group adoption. But I like to see through the answer of the different criteria where we want to go with this architecture document, and if let's say it's comprehensive and mature enough in the coverage for as an architecture for network digital twin, and if we can lay down based on this architecture document a set of let's say research questions or challenges that could feed in fact research into the research group on these questions, because we have seen that there are also other drafts, other projects working on that. So I think it's an interesting trend. And I think we need also maybe to articulate a bit some of the research directions that we could explore in the research group. And I think this architecture document could be a foundation to, let's say, identify or highlight such directions. So this is for me as a participant some feedback I would like to provide for the call for research group adoption. I would put that into the mailing list, but I will leave also Jérôme maybe to steer this discussion.
Thank you, Laurent. Thank you, Cheng. I think, this draft has been presented multiple times. Has been made. I think it was very interesting. The last slide you present, Cheng, with the different, enablers that we need for digital twin networks, and I think it can be really useful for actually articulating this discussion of what we need actually for having this digital twins. So I think it could be a very good point also to have this as really serving as a purpose for the discussions. And maybe more formally now for the call for adoption. So as Laurent mentioned, so there is a kind of let's say it's not formal, but it's something that we define in Emergy as a procedure for the call for adoption. So as we already did for previous documents. So if I think the first thing as usual is to have the different feedback on the mailing list and to update the draft. And then if after this, maybe the next round of discussion you might have with maybe with Laurent or with other participants that provide you some discussion, some comment after this meeting, we can then of course send the call for adoption of the mailing list, and it will be done somehow offline on the mailing list to have also the opinion of more people, because most of the time there are more people that express their opinion in that case regarding the quality of the document, the scope, or which cases can support the group, and so on. So as we say, yes, there is this procedure. I can send you the link as well if I will find it, just to maybe recall what we have defined for that.
Okay, thank you, Chair.
There's some comments on the chat, right? Okay, there are some, I think, quite a lot of comments in the chat. Maybe we can copy paste and in the minutes for further discussion, because I think we have to move to the next presentation. The next one is with the AI framework for network management. So it's Pedro.
Hi.
Hello, Pedro.
Can you hear me?
Yes, perfect.
Okay, so I will just presenting this new draft that is one evolution from one previous draft we have. Is in relation, as you can see here in the title, in relation to definition of artificial intelligence framework for network management. Next slide, please. Thank you. Okay, so in general, from the context of this draft and this framework, so we know that automating the network management with AI enables computer networks and infrastructure to grow. And we are currently dealing with exponential growth, thinking, for example, in IoT and these last digital twin functions that we are seeing. So there are a lot of hurdles that must be resolved in network management that AI can do. Okay, so several mechanisms have been to define to achieve these AI functions, but they must interoperate in some way. So we need some framework. That's the key of this draft, is to define this framework that is needed to ensure the seamless connection among all components and participants in this network management. Like, for example, we must define one ontology, so everybody, all components are talking about the same concepts and things like that. We need to define some kind of interfaces for different components, so the operation must be more or less well known by all of them. And finally, we need some method to assess the correct handling of those elements. So, for example, somebody can validate if one element, one component is actually doing what it must is supposed to do, and actually also, for example, for some developer or integrator to find out that the specification of components is actually what they need, not just the component is working as expected, but also the component fits with the needs of some software. Next slide, please. So the background of this is quite straightforward. We begin with the definition of virtual computer and network system. Today, they have high degree of flexibility and reliability. And as you all know, SDN and FV conceptually are centralized, only conceptually, but they can be distributed in implementation, and they reuse functions as software. So we are now talking about enormous flexibility and enormous amount of functionality that we can manage in order to build the network. Okay, so this is increasing the complexity of underlying systems, and they must perform dynamic adaptation in order to be optimized for different workloads and different scenarios. Next slide, please. In addition, additionally, from the background, we also have that I want to remain this, is that we are all, everybody is very familiar with the concept of machine learning and how it is being applied into the network. But again, I want to insist that AI is not machine learning, and there are a lot of benefits from AI beyond machine learning, like, for example, perception, reasoning, and planning that must be exploited for network management. As you know, many people know already, I've been collaborating with this group in this sense, in order to provide some kind of challenges, or at least some kind of topic for discuss in this direction. So I retake this. And again, I insist that intelligence, for example, is different from intelligent. In this case, we are dealing with the data gathering and management. For example, for building one digital twin, or just demonstrating some hypothesis or some for network management. We need a lot of data, and we need to gather that data, and we need to do that with some systematic methods. So they are also needed in this framework that I'm discussing today. And on the other hand, intelligence emphasizes on how that data is actually processed. So we have machine learning, we have other kinds of interpreting ways of interpreting the information. So we do that intelligently. So that's the main difference in this sense. Next slide, please. So I just wanted to give a name to this framework. INEMA. And INEMA is intended to be a generic, scalable, and deployable, and trustworthy AI framework for network management. The idea is to provide the roots for designing, deploying, instantiating, scaling, and validating AI solutions for network operation and management. And also, the framework will be particularly focused on end-to-end network management, because currently there are many focus on this side, and many interesting workflows are being dispatched from the end-to-end services, and we need to deal with them particularly. So key components on this framework, we have, of course, the data framework itself is part of this, how to define the data that is being acquired, how to model that data, store and distribute any kind of data. This part, for example, is also related to the data collection that has been previously discussed in terms for providing that data to build one digital twin. The data framework will be interconnected to this kind of data collection, also functions for aggregating data in the sources and things like that. So in addition to the data collection and data formatting, modeling, etc., the idea is that this component provides also some way of communicating the data efficiently to the elements that need that. Okay. In addition, we have the AI modules. They are functions mainly that are implementing the processing of the data individually or collectively. We have many schemes or many organizations of these kind of modules that are sharing information and that can do individual processing or collaborative processing in this sense. We have also end-to-end or global intelligent tasks that must be addressed. So these AI modules will collaborate in order to achieve these tasks. Okay, and finally we have what we define the hub. Will receive all the data, knowledge, and all decisions, etc., and will be shared again with all modules. So all information will be shared in this hub. So all modules can access the information, previous, for example, previous reports, previous notifications, previous data, current data, etc. And also, after one module has finished its work, we'll provide this information to this hub. This hub is being not just the hub. This schema is currently being used by many, let's say, intelligence frameworks to collect intelligence information, to manage that information, and to also, let's say, to provide the information to the interested stakeholders. All that process operations and processes must be, let's say, organized, no, by this AI framework. Next slide, please. As an overview of this operation, so we will first have the. I don't see that, but I suppose the slide is there. we will first have the, I now say it, the data collection sub-process. This is, again, I just summarize it here. It retrieves the performance measurements from the computer or network system that is being managed. In second, we have a reasoning sub-process that receives the collected data and receive, for example, additional context. I also mentioned this. It could be some kind of information that is provided by external elements that are from outside the network. I call them those external events or external event. External events, let's say. Well, and that information will be used by to find out the rules that are governing the current situation of the network. Then the third sub-process will be the solving sub-process, that gets the situation and rules previously obtained to build some dynamic knowledge graph. That means to gather together all the knowledge that represent the current situation of the network. The knowledge graph, of course, must follow some particular ontology, as I defined before, and it is worked in this solving process. The knowledge graph base is worked in order to find an acceptable situation. So the actions that must be applied to this knowledge graph in order to find one acceptable situation will be later in the next sub-process, by the planning sub-process, will be used to correct the network or to let's say adapt the network to some current situation or future problem, to prevent future problems. Okay, and how to do that is the final sub-process. The planning sub-process will get the actions that must be executed in order to achieve this correct acceptable situation, and plan them how to apply them into the network and, to ensure they are correctly enforced in the network. Next slide, please. In addition to this operation, we in the draft we also define some concepts that must be, let's say, researched and also organized in this kind of framework. Like, for example, this particular support for the closed loop. Okay, all management solutions, especially the automated management solutions, are aware of some kind of closed loop. So, but we need to define particularly how this closed loop can be implemented. So we need to, in this AI framework, we need to ensure that there are some, let's say, interfaces and some data formats that are particularly focused to allow the management solutions to ensure this closed loop can be, let's say, can be real, because the closing the loop is straightforward by implementing one single management solution. But when we are talking about different solutions that are interoperating, that is much more difficult. Okay. In addition, we also must deal with the concept of network intelligence. Again, I insist there's the difference from intelligent in general, no? But with me, that this means that data analytics that are complementing the AI methods, like, for example, incorporating a target-centric automated intelligent methods. That means that we have some kind of target definition for the network management solution, and the network intelligence processes will just try to find and get all the information required in order to accomplish that target. It's not just to watch the network to see what is happening. No, it's the opposite. In this case, we first establish a target, and then we work in order to find out evidence or find out any data that is required to demonstrate or to achieve the target in general. Okay. Next concept is the external event detectors. Again, I insist is to get. I discussed about them previously, but is to include in the AI framework. We need to model how information from outside the network will cross the boundaries and be introduced inside the network management solutions, and how to correlate that information can be correlated with what is happening inside the network, let's say performance measurements. So all of these will be also or must be also some kind of defined in this framework. Next slide, please. And two other concepts are the anticipation of network requirements. Instead of just exploiting AI for predicting what we are currently doing, for example, for machine learning, we are predicting what can be the near future. But instead of just doing that, we can focus on what I was defining about as anticipation. Let's say to find the situations and the events that will be dispatched or will be surely happening, where we can be sure they are happening. So we must anticipate the impact of in the network of some, for example, let's say one flash crowd event that is happening, so we can know exactly what that will trigger in the network. and we can anticipate to that. But it's not just prediction. It's not something that we can fail. No, it's something that's sure. So we can focus. We can have a particular focus to this because we will have much more time to analyze. For example, in the case of digital twins, we can, one situation that we anticipate, we can input that to the digital twin and see what can happen. The digital twin can say, oh, well, this is most probably to happen. It's okay. Or not, or we can say the opposite. But in these cases, I insist, it's anticipation, not just prediction. So it can be a bit different only, but at the end, when you think about the implications of in the definitions and implementation is very different. And finally is the reasoning. Support for intelligent reasoning is there are many methods that, for example, the machine learning and even, for example, particular neural networks that are quite good on obtaining some kind of classification or prediction from some data. Okay, but the full reasoning process must be, let's say, researched, in terms of to be modeled and to be, for example, complemented with metadata and things like that, so we can, for example, achieve some kind of explanation or find out some explanation to the actions that are automatically obtained by this AI framework, insisting in reasoning, of course. Next slide, please. And finally, it's just the most, let's say, just to highlight the most important issues that I find here in this AI framework would be just to define common interfaces. So we need to define the gaps. We don't have interfaces for allowing several AI modules to talk to each other. And that is important because in the future we will have several vendors that can provide specific functions, AI functions, that we will go in one direction or another, and most of them can be able to talk to each other. So it's important to define these interfaces, including the ontology I previously discussed. Okay, so also the component assessment and quality assurance is another thing that introduced before, is to standardize or define some kind of common methods to find out the quality of one component, to ensure it fits with the quality we are expecting, and to ensure it fits with our requirements. In addition, is the synchronized concepts and ontologies. This means that when different stakeholders are working with different concepts, they must be exchanged together in order to ensure that, for example, again, I said several AI modules and the network elements all are talking the same, are knowing the same concept. But when one new entity is dealing with one, is creating one new concept, how that will be automatically communicated to the other elements, so the other elements can be aware of this new concept. And finally, is how to, in some way, limit the information dissemination. As you know, if we are working in one new arena with several AI modules talking to each other, when we introduce some information, sometimes I will say that, yes, sometimes we want that information to be just disclosed to some elements, not all the elements. So how we are able to limit this? I don't want to talk about really bad mechanisms for that, but we need to in some way limit the scope, limit the level of dissemination of some information. That's all.
Yeah, because
I'm sorry.
Already over time.
I'm sorry. I didn't know. That's all. I'm sorry, and next
think
slide
you have-
is the end. So I finished.
Okay. Yeah, you have a lot of good inputs to the discussion, but we have to be strict on
Yes,
time.
I'm sorry,
Olga,
I'm sorry.
just very quickly, Olga, if you have something. Olga? Okay, Olga, we cannot hear. Yeah.
Oh, sorry. Just one comment. Like, I think it would be beneficial to add maybe the intent-driven approach to the AI framework. Because I do see that you have kind of mentioned other context in one place, but also and common interfaces. But I do believe it would be beneficial to say how it relates to the intent-driven approach and how they can coexist together, because I do believe there is a intent-driven approach that would be beneficial in the AI framework going forward.
Okay, thank you. I take note. I will try to let's say interconnect this AI framework with the intent-based approach. We are also already in this way, but I will particularly take a look at that. Thank you.
Thank you.
Okay, we really have to cut because others may have sessions to join. Thank you, everyone, for the participation on this last presentation from Pedro. I mean, there is a draft also associated to that. So if you have any comments, you can bring that offline to the mailing list or reach out to Pedro and the authors. And we will have to, in fact, consider how this activity falls into the activity of the research group. It connects maybe with other activities. So I think this is an ongoing conversation for this topic, and it's good to see a bit of activity there. Thank you, everyone. Jérôme, maybe you have some words of conclusion?
No, thanks everyone for participating. And yes, for the last presentation, I will share also some thoughts on the mailing list and also with Pedro. I have some questions, but I think it's too late now to handle them. So thank you all, and yes, we'll send minutes, and we'll keep in touch in mailing lists.
Okay, thank you, everyone. Bye-bye. Have a good IETF week.